Hello everyone, welcome back to our channel gsipucmysuru. This is the third session from the 8th chapter, that is modulation and demodulation. In the last session we discussed about the derivation of an instantaneous equation of an AM wave, that is VAM equals Vc sin omega Ct plus MAVC by 2 cos of omega C minus omega m of t minus MAVC by 2 cos omega C plus omega m of t. This is the instantaneous equation of an amplitude modulated wave anta last class alli ನಾವು derive ಮಾಡಿದ್ವಿ. Apart from that, we also saw what is called as the frequency response of an amplitude modulated wave. Frequency response is nothing but a graph which is plotted between the frequency and the amplitude of a amplitude modulated wave. So alli ಮೂರು component ಬರುತ್ತೆ. ಆ ಮೂರು component one is the carrier component which is having a frequency of Fc and amplitude of Vc. This is a graph between frequency and amplitude, and we will be having two side bands. One will be called as the lower side band, the other one will be called as the upper side band. The lower side band frequency is Fc minus Fm, the upper side band frequency is Fc plus Fm, but both the side bands is having an amplitude of Ma into Vc divided by 2 anta ನಾವು ನೋಡಿದ್ವಿ. And we had also seen what is called as MA. MA is nothing but the modulation index which was given by Vm divided by Vc anta nodidvi. It is a ratio of the amplitude of a modulating signal to the amplitude of a carrier signal. For proper modulation, that is for proper amplitude modulation, Vc must be greater than Vm. Vc Vm ಗಿಂತ ಗ್ರೇಟ್ ಆಯಿತು ಅಂತ ಹೇಳಿದ್ರೆ MA value will be less than 1. So MA value will lie between 0 and 1. The maximum value of this MA is equal to 1 and the minimum value of MA is equal to 0. So this modulation index can also be called as the degree of modulation or the modulation factor. It's one and the same. Modulation index, degree of modulation or the modulation factor, it's one and the same, that is equal to MA, which is nothing but the ratio of the amplitude of a modulating signal to the amplitude of a carrier signal, and it is not having any kind of a unit, it is just a number which lies between 0 and 1. If the amplitude of Vm is greater than Vc, if the amplitude of Vm is greater than Vc and hedadre, there will be distortions in the final signal, that is distortions in the amplitude modulated wave, and such type of modulation will be called as over modulation. So distortion anta heladrenu, distortion is nothing but the disturbances athwa unwanted noise signals actual signal jotege mix up aguva chances irutte. So what is this over modulation? If the amplitude of a modulating signal is more than the amplitude of a carrier signal, then there will be distortion in the amplitude modulated wave, and that type of modulation is called as over modulation. So for proper modulation, we have to make sure that Vc is greater than Vm. So in amplitude modulation, the amplitude of a carrier signal increases during the positive half cycle of a modulating signal, and its amplitude decreases during the negative amplitude or the negative half cycle of a modulating signal. That is, modulating signal nange hee ತರ ಇರುತ್ತೆ, carrier signal will be constant. So in the amplitude modulation, if I am going to consider this as the Vc line, the amplitude of this carrier signal increases for every positive half cycle and it decreases for every negative half cycle. So the extent to which the amplitude of a carrier signal is varied is called as the modulation index or the degree of modulation or the modulation factor. So let me come up with the definition once again. The extent to which the amplitude of a carrier signal is varied by the modulating signal is called as the modulation index, the modulation factor, or the degree of modulation. Clear? Now let us try to solve some of the problems with the expression for the instantaneous equation of a EM wave and this. Here's the first problem. An amplitude modulated wave has a carrier amplitude of 50 volts. Carrier amplitude anta helidre it will be denoted by Vc and that is given as 50 volts. And signal amplitude of 20 volts. Signal amplitude anta helidre it is nothing but the modulating signal or the actual signal which has to be transferred from one place to another place. That is nothing but the amplitude of a modulating signal which will be given by 20 volts. What is the modulation index and the percentage of modulation? What is the modulation index anta helidaga illi avaru mention madidare in amplitude modulated wave. So what is the modulation index andre it will be denoted by MA and they have also asked the percentage modulation which is nothing but percentage MA. Idannondu heladu martidde. So percentage modulation will be denoted by capital letter M which is equal to Vm divided by Vc into 100. Idannu madidre namage percentage modulation barutte. So let us solve this. MA kottidare, MA you have to find out. They have given Vc and Vm. Problem is very much simple. We are having a direct formula. MA equals Vm divided by Vc which is equal to Vm value is 20 volts and Vc value is 50 volts. So after solving we will be left with 0.4. No unit for this MA. It is 0.4 volts or 0.4 hertz. Atara enu baribedi because we are not having any unit for this modulation index. So this MA value is equal to just 0.4. Problems are very simple in this particular chapter, but only thing is you have to remember the formula. Percentage modulation, percentage MA which will be denoted by M is nothing but Vm by Vc into 100. Vm by Vc we have already found out. So 0.4 into 100 which is equal to 40%. So this is the final answer of the first problem. Clear? Now let's look at the second problem. A carrier wave of frequency 10 megahertz. A carrier wave of frequency anta naru kodabodu athwa a carrier wave of 10 megahertz. 10 megahertz. Here sometimes they may mention or may not mention that this is an amplitude, this is frequency anta. Looking at the unit what they have given, you have to identify whether it is frequency or amplitude anta. 10 megahertz. Hertz is the unit for frequency. So a carrier wave of 10 megahertz. Carrier wave anta helidaga it is the frequency of a carrier signal. So Fc is equal to 10 megahertz and peak voltage of 14 volts. Illi a carrier wave of 10 megahertz and peak voltage of 14 volts. Onde sari kottidare onde sentence alli. So the peak voltage of the carrier signal is 14 volts. Is amplitude modulated by a sinusoidal wave of 5 kilohertz. Amplitude modulated by a sinusoidal wave. Andre ಒಂದು ಕ್ಯಾರಿಯರ್ ಸಿಗ್ನಲ್ ಇದೆ, ಆ ಕ್ಯಾರಿಯರ್ ಸಿಗ್ನಲ್ ಜೊತೆ ಇನ್ನೊಂದು ಸೈನುಸಾಯ್ಡಲ್ನ ವೇವ್ ತಗೊಂಡು ಅದರ ಜೊತೆ ಆಂಪ್ಲಿಟ್ಯೂಡ್ ಮಾಡ್ಯುಲೇಷನ್ ಮಾಡಿದ್ದಾರೆ. ಸೊ sinusoidal wave of 5 kilohertz anta helidre it is equal to the frequency of a modulating signal which is given by 5 kilohertz and amplitude 6 volts. They are talking about the sinusoidal wave of 5 kilohertz and amplitude 6 volts. So 6 volts is nothing but the amplitude of a modulating signal. So Vm is equal to 6 volts. Write the equation of an EM wave. Equation baribeku. And what is the bandwidth of the modulating signal? You have to find out the bandwidth of the modulating signal. Fc is 10 megahertz, Vc is 14 volts, FM 5 kilohertz, VM 6 volts. You have to write the equation and also find out the bandwidth. So the equation of an AM wave will be given by VAM equals Vc sin omega Ct plus MA Vc by 2 cos omega C minus omega M of t. That will become a TDS equation. Adikkinta munche before splitting that sin A into sin B banditalla, that is Vc of 1 plus MA sin omega Mt of sin omega Ct. You can use this simple equation in order to find the instantaneous equation of an AM wave. But there I don't know the value of MA. MA equals VM divided by Vc. Adanna calculate madkolana. VM is equal to 6 and Vc is equal to 14. So I will be left with 6 divided by 14, 0.428. Omega M kottilla, FM kottidare, FC kottidare. Omega M equals 2 pi FM. So 2 pi into FM value is 5 into 10 to the power of 3, which is equal to 10 pi kilohertz. 5 2s are 10, pi into 10 to the power of 3. Let me write that as it is, into 10 to the power of 3 hertz. And omega C equals 2 pi FC, which is 2 pi into FC value is 10 into 10 to the power of 6, which is equal to 20 pi into 10 to the power of 6 hertz. Right? Now let us substitute these equations or these values directly to the formula. VAM equals Vc value is 14, Vc value is 14, 1 plus MA value is 0.428. It is not having any unit, so just 0.428. Sin omega M value is 10 pi into 10 to the power of 3t. You need not simplify this sin term hage bitre aitu into sin of omega Ct, that is 20 pi into 10 to the power of 6t. So this is the final equation of an amplitude modulated wave. So idinna kandidadaitu. Next we have left with the bandwidth. So bandwidth equals 2 times of FM. Haudalva? 2 times of FM. FM they have given 5 kilohertz. So 2 into 5 into 10 to the power of 3, which is equal to 10 kilohertz. So bandwidth of this AM wave is equal to 10 kilohertz. Problems are simple, right? Only thing is you for solving the problems use this particular equation instead of writing that expanded version of this sin A and sin B. Clear? Let us now look at the third problem. A carrier wave with an RMS voltage of 3 volts. Here in this particular problem, they have given us the RMS value, but we are concerned with the peak value, not the RMS value. But we know the formula to calculate the peak value from the given RMS value. So let us write it as it is, a carrier wave with an RMS value. So Vc RMS, let us denote that as Vc RMS, is given by 3 volts. And a frequency of 1.5 megahertz. Carrier wave ಬಗ್ಗೆ ಮಾತಾಡ್ತಾ ಇದ್ದಾರೆ. ಅದರದ್ದು frequency ಅಂತ ಹೇಳಿದಾಗ it is denoted by FC, which is given by 1.5 megahertz. Clear? Is modulated by a sinusoidal wave with a frequency of 500 hertz. Sinusoidal wave the frequency, I mean to say a modulating signal frequency FM is equal to 500 hertz and amplitude of 2 volts RMS. Again, the voltage is not given in peak, they have given in RMS. So Vm RMS is equal to 2 volts. Write the equation of a resulting signal. You have to write the equation for this particular signal. But they have given the RMS value but not the peak value. So you have to calculate that peak value and then write the equation. Vc is equal to athva Vrms is equal to Vc divided by root 2. Vc RMS is equal to Vc divided by root 2. The RMS value is equal to peak value divided by root 2. But Vc is equal to root 2 into VC RMS. I have just cross multiplied. So VC is equal to root 2 into 3. Root 2 into 3 gives me 4.242 volts. Similarly, Vm equals root 2 into Vm RMS. So root 2 Vm RMS is given as 2 volts. So I will be left with root 2 into 2 gives me 2.828 volts. So these are the peak values. You have to find out the equation. Equation is VAM equals VC of 1 plus MA sin omega MT of sin omega CT. But I don't know the value of MA also. So let us calculate the MA value. MA equals Vm divided by Vc. Vm value is 2.828. Vc value is 4.242, which gives me 0.66. MA value is 0.66. So just substitute over there. VAM equals Vc value is 4.242 of 1 plus 0.66 sin omega m omega c gotilla. Let us calculate that. Omega m equals 2 pi fm, which is 2 pi fm value is to 500, which is equal to 1000 pi or 10 to the power of 3 pi hertz. Adhe thara omega c equals 2 pi fc, which is equal to 2 pi. Fc value is 1.5 mega, 1.5 into 10 to the power of 6. So which is equal to 3 into 10 to the power of 6 pi hertz. So let us substitute these two values directly in the expression. Sin of omega m value is 10 to the power of 3 pi of t of sin omega c value is 3 into 10 to the power of 6 pi of t. Retain that pi value as it is and just solve the problem. So usually the peak values of the voltages will be given. In case if they are going to give you the RMS values of the voltages, then you have to find the peak value and then substitute those values. Clear? Now we will move on to the fourth problem. A sinusoidal carrier voltage Vc equals 80 sin 2 pi into 10 to the power of 5t is amplitude modulated by a sinusoidal voltage of Vm equals 32 sin 2 pi into 10 to the power of 3t. Write the equation of the EM wave and draw the output frequency spectrum. Equation ಬರಿಬೇಕು, frequency spectrum draw ಮಾಡಬೇಕು. So in this particular problem they have given the equations directly, Vc and Vm. Vc is the instantaneous equation of a carrier signal. Vm is the instantaneous equation of a modulating signal. They have given that directly. Now we have to find the equation as well as the frequency spectrum. Compare these two equations with the actual equation that is Vc sin omega Ct. Vm equals Vm sin omega Mt. So compare, let me call this as equation 1 and 2 and these as equation A and B. Compare 1 and A, 2 and B. 1 and A compare ಮಾಡಿದಾಗ Vc ಜಾಗನಲ್ಲಿ I am having 80 volts. Omega C ಜಾಗನಲ್ಲಿ I am having 2 pi into 10 to the power of 5. ಹೌದಲ್ವಾ? ಅದೇ ಥರ if I am going to compare equation 2 and B, in a place of Vm we are having 32 and omega m is 2 pi into 10 to the power of 3. ಹೌದಾ? The expression or the equation is Vam equals Vc of 1 plus Ma sin omega m of t sine omega ct. We don't know the value of MA, so let us calculate that first. MA equals Vm divided by Vc. Problems are very simple, only thing is you have to remember this formula. Vm value is to 32, Vc value is equal to 80, then the answer will be 32 divided by 80 gives me 0.4. No unit for that, so leave it as it is. So Vam equals Vc value is 80 of 1 plus MA value is 0.4 sine omega m 2 pi into 10 to the power of 3t. Omega c value is to 2 pi into 10 to the power of 5t. This itself is the equation of an amplitude modulated wave. So, we have done with this. Next, draw the frequency spectrum. Frequency spectrum, this is the frequency and this is the amplitude. I will be having 3 different lines. This is the frequency of a carrier signal fc. Adardu value na nanu kandidibeku. Omega c is equal to 2 pi fc. Hoda? Omega c value is given 2 pi into 10 to the power of 5, which is equal to 2 pi fc. 2 pi cancel agtade, so I will be left with fc equals 10 to the power of 5 hertz. Let me calculate fm also. Omega m equals 2 pi fm. Omega m value is given as 2 pi into 10 to the power of 3. 2 pi fm, 2 pi cancel agtade, so I will be left with fm equals 10 to the power of 3 hertz. Hoda? So, fc is having a value of 10 to the power of 5 and the amplitude of this is Vc, whose value is equal to 80 volts. Now, the lower sideband frequency is fc minus fm and amplitude ma Vc by 2. Upper sideband frequency fc plus fm and amplitude ma Vc by 2. Let us calculate the amplitude also of the sidebands ma Vc by 2. This is nothing but the amplitude of sidebands. Ma value is 0.4, Vc value is equal to 80 divided by 2 gives me 0.4 into 80 by 2, which is equal to 16 volts. So, both these values are 16 volts. Hoda? But while calculating this lower sideband frequency and upper sideband frequency, fc minus fm, fc value is 10 to the power of 5 ಅನ್ನೋದನ್ನ ಪೂರ್ತಿಯಾಗಿ ಈ ತರ ಬರ್ಕೊಳ್ಳಿ. 10 to the power of 5 minus 1000 means, sorry, 10 to the power of 3 means 1000. Now subtract this. I will be getting 99,000, which is equal to 99 kilohertz. Adhe thara fc plus fm is equal to 10,000 plus 1000, which is equal to 101 kilohertz. 101,000. So, I will substitute ಮಾಡಿದಾಗ 101 kilohertz. So, this is 99 kilohertz and this is 101 kilohertz, whereas this can be written as 100 kilohertz. So, the lower sideband frequency is below this 100 kilohertz, that is 99 kilohertz, and upper sideband frequency is above this 100 kilohertz, that is equal to 101 kilohertz. Clear? While solving these sideband frequencies, please follow this method. 10 to the power of 5 minus 10 to the power of 3 equals 10 to the power of 2 ಅಂತ ಎಷ್ಟೋ ಜನ ಬರೆಯೋ ಚಾನ್ಸಸ್ ಇದೆ. ಯಾಕಂದರೆ ಎಕ್ಸಾಮ್ಸಲ್ಲಿ ಆ ಥರ ಬರೆದಿದ್ದಾರೆ. That will give you a wrong answer. So please follow this method and come up with this kind of answers, 99 kilohertz and 1 kilohertz. Clear? Now we'll move on to the fifth problem. A bandwidth of 15 megahertz is available for AM transmission. So bandwidth of 15 megahertz is available for AM transmission. If the maximum audio signal frequency used for modulating the carrier is not to exceed 15 kilohertz. If the maximum audio signal frequency ಅಂತ ಹೇಳಿದ್ರೆ it is FM and ಅದರದ್ದು maximum value ಕೊಟ್ಟಿದ್ದಾರೆ which is equal to 15 kilohertz. So let us name that as FM max, which is equal to 15 kilohertz. How many stations can accommodate within this band simultaneously without interfering with each other? So in this problem you have to calculate the number of stations that can accommodate. So idu eshtu anta. So the total bandwidth is given. The question is the total bandwidth is given over here. Ishtu dodda bandwidth, ishtu dodda frequency range is given. In this, the total bandwidth is 15 megahertz. How many number of stations can be accommodated? We are able to listen for 93.5, 92.7, 90.8, 100.6. Itara eshtondu bere frequency signals namge nama mobile phone alli capture madkolbodu. But when I am going to tune for some particular frequency, if I am going to consider this as 92.7, this 92.7 is audible up to a range of this. In the exact target, this is 92.7, but for some values below 92.7, that can be 92.6, 92.5, alli tankanu nange kelsutte. Above that anta helidaga 92.8, 92.9 alli tankanu kelsutte. So this is called as the bandwidth. So they have given us the total bandwidth of 15 megahertz. They have asked us to calculate how many single stations can be accommodated in this particular bandwidth. If the bandwidth of this particular station is this much, how many such stations can be accommodated in such big bandwidth anta our question. So let us calculate the bandwidth of a single station. Bandwidth of one station is equal to, bandwidth ke namge formula gotu, it is 2 times of FM. So 2 times of FM maximum value ne avaru kotirodrinda 2 times of 15 kilohertz, which is equal to 30 kilohertz. That is, this particular bandwidth, that is the bandwidth of one station is 30 kilohertz, but they have given a overall bandwidth of 15 megahertz. ಆ 15 megahertz ಅಲ್ಲಿ ಈ ಥರ 30 kilohertz ಇರುವಂಥ bandwidth signal ಎಷ್ಟು accommodate ಮಾಡಬಹುದು ಅಂತ. So for one station bandwidth is 30 kilohertz. Now for 15 megahertz, how many number of stations can be accommodated? Another question. So let us call this as XR. Let me denote that as number of stations itself. So what we are going to do? So number of stations for 15 megahertz is equal to 15 into 1 is 15 itself. 15 into 10 to the power of mega, it is 10 to the power of 6 into 1 divided by 30 into 10 to the power of 3. I have just cross multiplied. So 15 ones are, 15 twos are, 10 to the power of 3, 3 cancel aitu. So 1 divided by 2 is equal to 0.5 into 10 to the power of 3. Hage ulkonide 10 to the power of 3. So 0.5 into 10 to the power of 3 gives me 500. So 500 number of stations can be accommodated in a bandwidth of 15 megahertz anta artha. So try to understand the problem correctly and then solve the problem. They have given a total bandwidth of 15 megahertz and the maximum frequency of a modulating signal is 15 kilohertz. How many number of stations can accommodate in this particular bandwidth anta kelidare. Let us calculate first the bandwidth of one single station using this formula 2FM. So 30 kilohertz anta now calculate madidvi. So 30 kilohertz is a bandwidth of one particular station. Athara ಎಷ್ಟು number of stations can be accommodated in 15 megahertz anta keltaga it is equal to 500. So 500 number of stations can be accommodated in 15 megahertz bandwidth. Clear? So in this session we solved some of the problems related to amplitude modulation. In the next session I will be coming with a new topic. Until then, take care. Bye bye.